Okay, good morning, Professor David J. Okay, my topic for this morning will be it is a long video format on college algebra. This is now lesson number 18. This is a very interesting one, guys. Okay, I discovered the uh, solution or the concepts and how to explain the determinants of three equations and three unknowns. Okay, because the last time around I just give you two equations and two unknowns. So for this morning we will be discussing the more complicated one, so you could understand how the concepts was derived. Okay, let's proceed. This is now college algebra lesson number 18. The title of the topic for this morning will be, it's this morning now, it's July 27, okay. Determinants of three equations and three unknowns, meaning the solution of three equations and three unknowns by using determinants. So we will try to bring out the concept or the form of the equation and how to compute for the unknowns x, y, and z. It's a three variable thing. Okay. For three equations and three unknowns, it will be something like this. We are given equation number 1, equation number 2, and this will be equation number 3. So we are to bring out the solution of this by using determinants or the Cramer's rule, okay? Don't be bored. The topic the last time around was the simpler one. So for tonight, it is more the complicated thing, but at least I could explain to you fully the concept and how this equation was to be performed. Okay, let's proceed. We are given equation number 1, that is E1x, B1y plus C1z equal to D1. That will be equation number 1, where A1, B1, Z1, and D1 are all constants. And the unknown variables are actually x, y, and z. Equation number 2, it will be an A2x, B2y, Z2z plus D2. That will be equation number 2. It is still a three equation and three unknown, and the constants are different now. It will be A2, B2, C2, and D2. For the third equation, it's still three equations and three unknowns. They are all linear, so it will be E3x plus B3y, C3z, and this is D3. So for equation number 1, if you try to notice it, the subscripts are all 1, right? For equation number 2, the subscripts are all 2. Meaning to say, equation number 2 coefficients are different from the coefficients of equation number 1. For equation number 3, the subscript is 3. So all the constants are all different. Okay, we are lucky if there are some equal constants. Okay, let's try to bring out the solution of this by using determinants. For the value of x, it will be the determinant of x all over d, and for y it will be the determinant of y over d, and z will be just simply dz over d. So these are the three equations in order to be used in order for us to solve for the value of x, y, and z, but we must have to evaluate the four values. There are actually unknown four values, that is dx, dy, and dz, and the common denominator d. Okay? How we, what you call this, simplify the value or bring out the value of dx, dy, dz, and d, it will be something like this. For the value of d, okay, just bring out the coefficients from the three equations, the one that's on the left. Just bring out the equations. Write it as a matrix, right? So this the first column will be A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, that's the coefficients considering the left hand side, and that is actually supposed to be the matrix for the determinant D. Okay, meaning to say to compute for D, we must have to evaluate this matrix here. And the explanation of our book, in order for us to bring out the simplification of this, it will be something like this. Okay, I just follow this. It was derived from the book that it was like this, right? So the determinant D will be equal to, consider A1 first. A1 times the minor of A1. Later on, I will explain what's minor of A1. Minus B1 times minor of B1. This is plus. This is minus, right? Next one will be plus. Plus C1 times the minor of C1. Okay, let's try to bring out the minor of A1. The minor of A1 will be something like this. If we try to consider A1, okay, we try to cross out this row here, okay, and the downward column, okay. To bring out the minor of A1, cross out this row here and cross out this column downward, okay. So what remains is actually the one that was not crossed out is actually this one here, B2, B3, and C2, C3. So the minor of A1, the matrix will be B2, B3, and C2 and C3. Okay, you got it? We cross this row here, and we cross this column here downwards. So what remains that was not crossed out are actually B2, B3, B2, B3, and C2, C3. That's the minor of A1. Okay? What's the minor of B1? If we try to consider B1, okay? If we try to consider B1, we cross out this column here downward. Okay? Then we cross out again this one. Okay? So this was not crossed out, right? So what remains that was not crossed out, if we try to bring out the minor of B1, it will be A2, A3, A2, A3, and C2, C3. Okay? That's the minor of B1. And the minor of C1, this is C1, right? So we cross out this column here. Okay? Then we cross out again this row. So the one that was not crossed out are actually, this was crossed out, right? This was from the original B1. This was not crossed out. So what remains for the minor of C1, it will be the matrix A2, A3, and B2, B3. So this is A2, A3, okay? And B2, B3, and B2, B3. That is the way how we compute for the minor of A1, B1, and C1. Okay? So for A1, I will repeat it, it will be B2, B3, C2, C3. And for the minor of B1, it will be A2, A3, C2, C3. And for C1, it will be A2, A3, B2, B3. These are matrix, right? So if we try to compute for D, okay, we will take A1, then we will take the simplification of this matrix here. We know how to simplify a 2 by 2 matrix like the last time around, right? So we could compute for the equivalent of this one. Okay? Let's try to compute for the value of dx. For dx, this is the secret, okay? If we try to compute for x, we try to bring out the matrix for dx. And the proper ways will be done like this. If we are solving for x, cover x. Right? Then take this d1, d2, d3, place it here. In the one that you covered. So the elements that goes inside the array or the matrix for dx, it will be, this is now all these, right? These are all b's and these are all c's. So this will now be in the formation DBC. Okay? You got it? DBC. If we are solving for x, we take this D1 here, we place it here. D2, D3, we place it here. So the formation inside will be D1, D2, D3, B1, B2, B3, B1, B2, B3, and C1, C2, C3. Okay, that's the way how to bring out the elements inside the matrix for the X. Okay, for the simplification of this, it is the same as the simplification for the determinant D. Okay, I will not give you anymore. For the value of dy, if we try to compute for d sub y, we cover y. Okay, we cover y. Then we try to replace this column here by the value d1, d2, d3. So what goes inside the matrix for d sub y, it will be in the formation A, D, C. So this is now A, D, C. Okay, you got it? You now know why on the second column it's all this. Because we cover y and then we replace by the value d1, d2, d3. Because we are solving for d sub y. So the formation is A, D, C. So this is A, D, C. Okay, I'll just change the separate. A1, D1, C1, A2, D2, C2, A3, D3, C3. That's the formation of the elements inside the matrix for dy. And if we try to compute for the value of z, we cover the column z here on this equation. Okay, we cover it. Then replace this column by the value d1, d2, d3. So the formation or how the elements will be arranged inside the matrix will be A, B, D, right? So this is now A, B, D. So it will be A1, B1, D1, A2, B2, D2, and A3, B3, D3. And for the simplification of this and this one, it is the same as in the simplification of the minors of D. Okay, but at least you now know how the elements inside the matrix was, arranged, right? You now know why this is EDC and this is EBD, and for the first one, it is DBC. Okay? Okay, let's try to bring out an example so we could visualize that previous concept. Okay? To use this one, we bring out an example so we visualize more. Equation number 1. X plus 2y minus 3 is equal to 9. That will be equation number 1. Equation number 2 will be 2x minus y plus 2z equal to minus 8. 3x minus y minus 4z equal to 3. That will be equation number 3. So this is equation number 1. This is equation number 2. And then this is equation number 3. The problem is asking for the value of x, y, and z using determinants. Okay, this is 3 equations, 3 unknowns, so we could use this concept over here. Okay, let's try to compute for the value of the determinant D. The determinant D, the elements inside are actually the coefficients of the left-hand side. This is 1, 2, 3, this is 1, 2, 3, 2 minus 1 minus 1, this is 2 minus 1 minus 1, minus 3, 2, and minus 4. Those are the elements inside the matrix for the determinant D. And to compute for D, we must have to evaluate this one. And to evaluate this one, we will start with the minors, okay? We will start with 1, 2, 3. The one at top. Right? To simplify this one, okay, we use this concept here. It will be 1 times the minor of 1, okay, minus 2, we are following this, okay, times the minor of 2, plus, this is plus, right, plus open quantity minus 3 times the minor of minus 3, and the minor of 1, the minor of 1, if we try to bring out the minor of 1, we cross out this column here, then we cross out this row here. So what remains for the element inside the matrix for the minor of 1, it will be -1, -1, and 2, and minus 4. So this is negative 1, negative 1. This is 2 and negative 4. It is something like this. We cross out this column here, then we cross out this row. So what remains, the number that was not crossed out should be the elements inside the matrix. It is negative 1, negative 1, 2 and minus 4. So this is minus 1, 2 and negative 4. Okay? Minus 2 times the minor of 2. The minor of 2, it is the same like this, right? This is 1, 2, 3, 2 minus 1, 2. This is 3 minus 1 minus 4. So to bring out the minor of 2, we cross out this row here. Then we cross out this column. So all those numbers that was not crossed out should be the one inside the matrix for the minor of 2. So it will be 2 and 3 and 2 and minus 4. This is 2 and 3 and this is 2 and minus 4. Okay, so you now know how it was bring out, right? How it was bring out. Okay, let's proceed with the minor of negative 3. The minor of negative 3, okay, it's still the same this one. We cross out this row here. It involves the 3, negative 3, right? Then we cross out this column. So all those numbers that was not crossed out should be the elements inside the minor of minus 3. And it should be 2 and 3 and negative 1, negative 1. So this is 2 and 3, negative 1 and negative 1. Okay, you got it, guys? It was like that. You cross out this row, you cross out this column. What remains that was not crossed out should be the elements inside the matrix minor of negative 3. 2 and 3, negative 1, negative 1. This is 2 and 3, negative 1, negative 1. Okay, let's try to bring out the simplification. If we try to simplify this one, from the previous discussion the last time around under the 2 by 2 matrix, we have done that already. So this is 1. If we try to simplify this, multiply this one. Negative 1, negative 4 will be plus 4. Okay? Minus the product of negative 1 and 2. You subtract it. So minus minus, it will now be plus. So this will now be plus 2. Because a negative 1 times 2 will be negative 2, but we are subtracting, so it will now be plus 2. Minus 2, we are on this. And we try to simplify this one, we take the product of this. 2 times minus 4 is minus 8. Okay? Minus the product of 3 and 2. Positive, positive, but we are subtracting, so this should be negative 6. Right? It was the same as the last previous lesson, right? Under the 2 by 2 matrix. This is a plus and a minus, this will now be minus 3. And the product of 2 times minus 1 will be minus 2. Okay, and the product of 3 times minus 1 will be minus 3. But the operation is subtraction, so this will now be plus 3. Okay, if we try to simplify this one, okay, I will not go into detail now. We are lacking time. The value of the determinant D will be 31. Okay, but the procedure on how to evaluate this matrix here, what we have done on the last time around, the product of downward minus the product of upward. Okay, let's try to bring out the value of dx. For the value of dx, I put it here, the matrix will be 9 minus 8 and 3, 2 minus 1 and minus 1, minus 3, 2 and minus 4. We will be using this one. How come it was like that? It's like this. If we try to bring out the matrix for dx, we cover the column for x, right? Then we replace that by d, the value on the right hand side. So the first column will be 9 minus 8 and 3. 9 minus 8 and 3. Next one will be, just follow the whiting. This is 2 minus 1 minus 1. And for the z, it will be 3 plus 2 and minus 4. Okay? So meaning to say, these are the elements inside the matrix for the determinant x. And to simplify this one, okay, we start with the minor thing, okay? We start with 9. We start with 9. Okay, we cross out 9, downward. Then we cross 9 on the column, right? So what remains for the minor of 9 will be negative 1, negative 1. This is 2, negative 4. Negative 1, negative 1, 2, and negative 4. Okay? We cross out the first column and the first row. Okay? To get the minor of 9. The next thing is minus 2. Okay? So to get the minor of 2, we cross out this one and cross out again this one. This is minus 1, right? Okay? So the elements or the numbers that was not crossed out, when taking the minor of 2, it will be negative 8 and 3 and 2 and minus 4. This is negative 8 and 3, 2 and negative 4. Okay? And for the minor of negative 3, this minus, right? We are following this formula. So this is plus. The next one will be plus open quantity negative 3. And the minor of negative 3, we cross out this one column, and then we cross out this row. This was not crossed out, right? So what remains will be negative 8 and 3 and minus 1 and minus 1. So this is negative 8 and 3 minus 1 and minus 1. And to simplify this one, this is a 2 by 2 matrix now. You take the product of this downward minus the product of this upward. Okay? A negative 1 times the minus 4 will be plus 4. Okay? A negative 1 times the positive 2 will be negative 2, but the operation is subtraction, so this is now plus 2. Right? Minus 2. Minus 8 times minus 4 will be positive 32. Okay? 2 times 3 will be 6. They are both positive. The operation is subtraction, so this is minus 6. Okay? Minus 3. A plus in minus 3, this will now be minus 3. A minus 8 times minus 1, they are both negative, so this is plus 8. A 3 times negative 1 will be negative 3, but the operation is subtraction, so this is plus 3. And if we try to simplify this one, what comes out for the value of dx will be negative 31. So by using the first formula here, x now should be the determinant of x all over the determinant d. It will be negative 31 over 31. Okay? It should be negative 1. That's the value of x. For the determinant of y, okay, we cover y here. Right? Then we replace this column here by this column. So the elements inside the matrix for d sub y should be 1, 2, 3. This is 1, 2, 3. We replace this covered column by 9, 8, and minus 3. This is 9, minus 8, and 3. Next one will be negative 3, 2, and minus 4. This is negative 3, 2, and minus 4. And again, to simplify this matrix here, we use the minor thing, this formula here. Okay, we start with 1. Okay, so this is 1. So to get the the minor of 1, we cross the first column, then we cross the first row, right? So what remains that was not crossed out is actually negative 8 and 3, negative 8 and 3, and 2 and minus 4. And that's the minor of 1. Minus, the next one is minus 9, right? And the minor of minus 9, just cross out this column here, then just cross out this row. This was not crossed out, that was the previous one, right? So the one that was not crossed out is 2 and 3, and 2 and minus 4. So this is 2 and 3, 2 and minus 4. The last one, this is negative 3, right? Negative 3. So this is plus open quantity negative 3. The operation here is plus, but the number 3 is actually negative, so I put a quantity. And the minor of negative 3, okay, is the same. You cross out this column here, plus this column. Okay, this was the previous one. So this was not crossed out. So what remains that was not crossed out is actually 2 and 3 and negative 8 and 3. 2 and 3, negative 8 and 3. And again, if we try to simplify this 2 by 2 matrix, that was the previous lesson, okay, it should be 1. Minus 8 times minus 4 will be positive 32. 3 times 2 will be 6. The operation is subtraction, so this is minus 6. Okay, minus 9. 2 times minus 4 will be minus 8. 3 times 2 will be 6. The operation is subtraction, so this is minus 6. A plus and a minus, this should now be minus 3. 2 times 3 will be 6. 3 times minus 8 is negative 24, but the operation is subtraction, so this is plus 24. And if we try to simplify this one, okay, I will not give you the other simplifications. The dy now is a positive 62. So by using equation number 2, y now will be the determinant of y over d. So it will be 62 over 31, because the value of d is 31, right? 31. And the value of dy is 62. So 62 over 31, the value of y is actually 2. Okay? For the matrix for dj, we cover this column here. Column is the one that goes up and down, right? Then we replace that covered column by the value 9 minus 8 and 3. Okay? So the elements inside the matrix for d sub z, it will be 1, 2, 3, 2 minus 1 minus 1, and 9 minus 8 and 3. So this is 1, 2, 3, 1, 2, 3, 2 minus 1 minus 1, plus this one, we replace this by 9 minus 83. So this will be 9 minus 83. And again, to simplify this matrix here, we use this minor thing over here. We start with 1, right? We cross this downward. We cross this row here. So what remains as an element for the minor of 1 will be negative 1, negative 1. This is negative 8 and 3. Negative 1, negative 1, this is negative 8 and 3. For the minor of negative 2, or positive 2, this is positive 2, right? But the operation is subtraction, so this is minus 2. We cross out this column here, plus this row. This was previously crossed out. Okay, so what remains as element or the minor of 2 will be 2 and 3 and negative 8 and 3. 2 and 3, negative 83. Plus 9. We'll take the minor of 9. The operation is addition, right? We're following this. Okay? 9. We cross out this column here, right? Plus this row. Okay? This was previously crossed out. Okay? So what remains that was not crossed out will be 2 and 3, minus 1 and minus 1, 2 and 3, minus 1 and minus 1. And to simplify this one, okay, it's the same. Downward minus upward, downward minus upward, downward minus upward. Let's do it. Minus 1 times 3 will be negative 3. This is negative 3. Minus 1 times minus 8 will be positive 8, but the operation is subtraction, so this is minus 8. Okay? Minus 2. 2 times 3 will be 6. 3 times minus 8 is negative 24, but the operation is subtraction, so this is plus 24. Okay? Plus 9. This is plus. We are following this, right? 2 times minus 1 will be minus 2. 3 times minus 1 is minus 3, but the operation is subtraction, so this should now be plus 3. And if we try to simplify this one, the value of the determinant of z is actually negative 62. And by following equation number 3 here, that z will be dz over d, it will be negative 62 over 31, and negative over positive will be negative, and the answer for z will be negative 2. Okay? And to check the validity of our answer, we use equation number 1. X plus 2y minus 3z equal to 9. Substituting the computed values of x, y, and z back here. What comes out after the simplification from the left-hand side, that is 9, is really equal to 9. It is true. So, meaning to say, our answer is correct. Okay, that's it, guys. How we solve 3 equations and 3 unknowns by using determinants. Just follow this one. Okay? How we bring out the elements inside the array for dy, dz, and dx, and also for d. For d, you just consider the, coefficients on the left hand side. That's to bring out the array for D. That's for D, right? A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay? And for the value of dx, okay, like what I said, if you are computing for the value of x, just cover this one, then replace this column by the coefficients on the right hand side. So it will start with D, okay, then B and C. So this is in the orientation DBC. For dy, it is in the orientation EDC, right? For Z, it is in the orientation ABD. So this is ABD. And for the computation of the minor, you now know how we bring out the minor simplification. Okay, that's it, guys. That's the solution of 3 equations and 3 unknowns using determinants. Okay, this is Professor David J. De Los Reyes. Good morning from Los Angeles.